So, why are transformers used? So here's a simple picture of a transformer. Now we're going to look at these in more detail when we do the electromagnetism unit. So we're not going to go too much into detail of how they work, but we'll look at the basics today. So you can see that they consist of this kind of square of metal and iron core, and you have these coils of wire around each side. And in simple terms, what they do is they take a voltage or potential difference and they increase the potential difference, or they take a potential difference and they decrease the potential difference. And that's to make the transfer of electricity more efficient. So to make sure more is useful and less energy is wasted. So in order to explain why transformers are used, I'm going to just recap something we did in previous lessons. So here we have a battery and we have some charges flowing. So we have some current flowing, and obviously we know that electrons go negative to positive, even though conventional current is positive to negative. It shows us very nicely the resistance model in the wire. So these charges, these electrons are colliding with the atoms in the wire, and that is resistance. And then it also shows us the temperature here. So what happens if we increase the current? Or how do we increase current? Well, we increase current by pushing the electrons with more force, which means we need to increase the potential difference. So if we increase the potential difference, we get more current flowing. What do you also notice? As we increase the potential difference, not only do we get more current flowing, but you can see that we get a greater rate of collisions in the wire. You can see that the energy being transferred to the atoms is much greater, and that results in the temperature of the wire increasing. Now that's really bad, because if the temperature of the wire increases, the resistance of the wire increases even more. And that's really bad, because now we've got the wire heating up a huge amount. We're going to have a lot of wasted energy. And if you're transporting energy across the country, that's really bad, because you're wasting loads of energy, and that's going to cost you lots of money that you can't get back. So how do we deal with that? Well, that's what we're going to look at, and that's what transformers are for. So firstly, a recap of another lesson: power equations. Power is voltage times current, or potential difference times current. Or we also looked at power is current squared times resistance. So what does this mean? This means that if you double current, you've increased power by how much? 4 times. If you can halve the current, what have you done? You've decreased power by 4 times. So current has a massive effect on the power, and therefore the heating of the wire. So what do step-up transformers do? So what they do is they increase the potential difference. They step up the potential difference. They make the voltage a lot higher. So here's an example: 25,000 to 700,000. They decrease the current. Now, this is really important. You can't just get free energy. So you can't just increase the potential difference without decreasing something else, because the amount of energy that you're transferring has to be constant. The amount of power you're transferring has to be constant. So if you increase the potential difference, the current must decrease so that the energy stays constant. If you want another explanation for that, well, we know that power is current times potential difference. So if we decide to double this, what has to happen? Current has to halve so that power is the same. So a smaller current reduces heating, which reduces wasted energy, which makes it more efficient, and of course reduces the cost of doing all of this. So what do step-down transformers do? Well, step-down transformers, before we go on to step-down transformers, we'll just explain step-up a bit more. So a smaller current reduces heating, which reduces wasted energy. This makes it more efficient. So here's an example. and you might have a current of 200 amps from the power station. The wasted energy we can figure out, or the wasted power we can figure out from these equations. Let's plug in the current and a kind of example resistance, which might give us 2 million watts. If we can halve the current, let's look at what happens. We're going to halve the current to 100 amps, and we'll see that we've decreased the power loss by 4 times. So they might ask you, to work these kind of things out. So here's a useful example for you. So what do step-down transformers do? They decrease the potential difference. They step down the potential difference. They decrease the voltage. What must increase to make sure that we don't get free energy? The current must increase. This means the power transfer is the same. This makes the potential difference safe to use in the home. If you tried to use 700 kilovolts in the home, what would happen? Everything would break. Your TV would break. Your phones would break. You'd probably all get electrocuted. And that would be incredibly dangerous. So we need to make the voltage a lot smaller. We also make the current a lot higher so that our appliances will work. If it was a factory, again, they would have a much higher voltage because they need more energy. So here's an extension question for you to think about. Which of these is more useful to work out the power loss in cables, and why? So I haven't talked to you about equation 1, but some of you might have figured out or seen there is this third equation for power, that's potential difference squared over resistance. You don't need this for GCSEs, but it's here as an extension. So pause the video now and think about this question. So the correct answer is equation 2. This is more useful to work out the power loss. Why is that the case? Well, in a wire has quite a small resistance. So if something has a small resistance, what's the potential difference across it? It's going to be quite small. So if you try and use this equation for a wire, you've got quite a small potential difference. And it's just not very useful, really. It's not really telling you as much as if we use the current equation. So here is the explanation written out. So pause the video now and read this equation. Read this explanation. So obviously, if you use both of these equations correctly, they would of course give you the same answer. But the important thing is that 2 is much more useful because current relates to heating and energy loss a lot more directly than potential difference. Okay, that is the end of today's lesson. You can now complete the final set of questions.